Section 5.1 is about factoring by grouping and factoring by pulling out the greatest common factor. So factoring is the process of finding polynomials whose product equals a given polynomial. That's what factoring is. And we are doing this to build up to eventually solving equations and using these in applications. But kind of a quick takeaway is factoring undoes multiplication. So for example, if I had 4x plus 12 as my expression, I could factor that as 4x plus 3. So what I've done is I've pulled out a factor of 4, like I'm undistributing. 4 and x plus 3 are the factors of 4x plus 12. And we would call 4 times x plus 3 the factored form of 4x plus 12. A polynomial that cannot be factored is called a prime polynomial. So for example, if I had 5x plus 3, these terms have nothing in common. Their greatest common factor is 1, so it's going to be prime. I can't factor it any further. A polynomial is factored completely when it's written as a product of prime polynomials. So for example, 4 can't be broken down any further, and neither can x plus 3, so it is fully factored in that form. So how are we going to factor a polynomial? Let's look at binomials first, meaning they have two terms. So what we want to do is we want to first determine the greatest common factor of all the terms of the polynomial. Make a factor tree if you need. Then we're going to express each term as the product of its greatest common factor and its other factors, and use the distributive property to factor out the GCF. So let's look at 12m minus 60. I'm going to make a factor tree for this one, but I'm not going to for all of them. Sixty is 5 times 12. 12 breaks down into 6 and 2, which is 2 and 3. Remember, to find the GCF, I collect the factors they have in common. Both of these have a factor of 2, another factor of 2, and a factor of 3. Big surprise, the greatest common factor is 12. So I'm going to rewrite each term as the product of 12 and its other factor. Now, whatever's left here is our remaining factors. So our remaining factors are 5 and m. So I have 12 times m minus 12 times 5. And then I could rewrite that as 12 times m minus 5. We're pulling out the greatest common factor. Let's work through a few more examples. So for problem 1, I have 52m plus 27p. 52 is 2 times 27, and I've got a 27 here, so the greatest common factor is going to be 27. I'm going to write the greatest common factors on the left here. So I pull out a factor of 27, so I've got 27 times 2, and then there's an m, plus 27 times p. This would give me 27 times 2m plus p. If I have 2y plus 5, well, that's going to be prime, because 2y and 5 have no factors in common. If I have 8x cubed plus 12x squared, that greatest common factor, the greatest common factor of 8 and 12, biggest number they have in common is 4. The greatest common factor of x cubed and x squared is x squared, so that's my greatest common factor. 4x squared times x gives me 8x cubed. 4x squared times 3 gives me 12x squared. So I could rewrite this as 4x squared times x plus 3. Let me change colors and do these next couple of examples. So the greatest common factor of 24, 15, and 3, well, 3 is our smallest option. 3 goes into 15 and 24, so my greatest common factor is going to have to include a 3. Then I've got k to the 9th, k to the 7th, k to the 4th. We're going to use k to the 4th. So I've got 3k to the 4th times 3 times what gives me 12? 8, 24. 8. 8k to the 5th minus 5k cubed plus 1. If I pull out that greatest common factor. For example 5 here, think of this as a times b plus a times c. What's the greatest common factor of a, b, and ac? Well, that's going to be a, which is x minus 3. So here our greatest common factor is x minus 3. So I can rewrite this as x minus 3 times x plus 4 plus 3x minus 1. Then I want to simplify this. So that's going to give me x minus 3 times x plus 3x gives me 4x. 4 minus 1 gives me 3. Now, if you're factoring with a negative coefficient in the first term, we always want to pull out that negative coefficient. So there's no negative leading coefficients. So for example, I have negative 18a to the fourth b cubed plus 6a squared b squared minus 15a cubed b. The greatest common factor in this case, the greatest common factor of 18, 6, and 15 is going to be 3. The greatest common factor of a to the fourth a squared and a cubed is going to be a squared. The greatest common factor of b cubed, b squared, and b is just b. So here's my greatest common factor. But I'm going to pull out the negative with me. So I have negative 3a squared b. Negative 3 times what gives me a negative 18? It's positive 6. I've got a squared b squared plus, oops, not plus, right? Because now we're pulling out a negative. I have negative 2b, because I already have an a squared and a b, plus 5a. So we pulled out that negative with us, so we always have to remember to change the sign.